Hello everyone and welcome to this session on what is nanotechnology. Nanotechnology is the manipulation of matter on a near atomic scale to produce new structures, new materials and devices. The technology promises scientific advancement in many sectors such as medicine, consumer products, energy and manufacturing. In this session you will learn about nanotechnology. So without further ado, let us begin with the session.
But before we begin the session, make sure to subscribe to our channel and press the bell icon so that you'll never miss any update from us.
The agenda for today's video will be the following topics. Firstly, I'll be introducing the concept of nanotechnology to you guys, and then I'll move on to the history of nanotechnology. When was it first started or used, and who coined the term nanotechnology, and other trivia related to it. Next, I'll move on to the applications of nanotechnology in various domains, and finally, I'll be talking about the future of nanotechnology. Now, before I begin with the video, please make sure that you subscribe to our YouTube channel and hit the bell icon for notifications. Introduction. Nanotechnology is the understanding and control of matter at nanoscale at dimensions between approximately 1 and 100 nanometers. As you guys can see in the image on your right, so that is a nano robot manipulating the DNA strand. So the dimensions of the DNA strand comes between 1 to 100 nanometers, and the nanobot is basically manipulating it. So this is called as nanotechnology, and specifically it is used in the biomedical field. This is one example of nanotechnology. And nanotechnology involves the imaging, measuring, modeling and manipulating matter at this length scale, that is at nano length. Now, before we move ahead, we have to assume or imagine how small the nano is. I mean, how small the dimensions of nano is. So, we all know that from the International System of Units, that is the SI units, the prefix nano means 1 billion, or we can also say it is 10 to the power of -9. Therefore, 1 nanometer is 1 billionth of a meter. So it is difficult to imagine just how small this is. So I will be giving out some examples for you guys to imagine how small a nanometer is. So the thickness of a sheet of paper is about 100,000 nanometers thick, and a strand of human DNA is about 2.5 nanometers in diameter. A human hair is approximately 80,000 to 100,000 nanometers wide, and a single gold atom is about a third of a nanometer in diameter. So this is the smallest indivisible particle of a gold atom, so it is 1/3 of a nanometer. Now let us move on to the history of nanotechnology. The ideas and concepts behind nanoscience and nanotechnology started with a talk entitled There is Plenty of Room at the Bottle. This was a paper or a talk which was given by the physicist Richard P. Feynman in the year 1959. So he gave this talk at the American Physical Society meeting in the California Institute of Technology, also called as Caltech, on December 29th, and he did this long before the term nanotechnology was used. And in his talk, Feynman described a process in which scientists would be able to manipulate and control individual atoms and molecules. So this was very far-fetched at this time period, that is 1959. But Richard P. Feynman, he was a visionary and he looked into the future and gave out what was possible in the future using the technology, that is nanotechnology. And after him, over a decade later, that is around 1974, in his explorations of ultra precision machining, Professor Norio Taniguchi from the Tokyo University of Science coined the term nanotechnology. And in the 1980s, K. Eric Drexler promoted the technological significance of nanotechnology phenomenon and devices through speeches and two influential books. He developed and popularized the concept of nanotechnology and founded the field of molecular nanotechnology. And this was all possible because of the evolution of microscopes. So in the earlier days, light microscopes with the capacity to magnify objects at 1500 times were used, and later electron microscopes which were used, and this had a magnifying capacity of 1 million times. And the revolution in the nanotechnology field came in the invention of scanning tunneling microscopes, also known as STMs for short, and this took place in the year 1981. And STMs could magnify objects at 9 million times, and nowadays scientists also use the atomic force microscopes to image matter at nanoscale. Now let us move on to the applications of nanotechnology. Matter such as gases, liquids and solids can exhibit unusual physical, chemical and biological properties at the nanoscale, differing in important ways from the properties of bulk materials and single atoms or molecules. Due to this unique phenomenon, novel or new applications are possible. As mentioned earlier, the invention of special microscopes, that is the STMs, gave scientists the ability to work at the nanoscale. The first of these new discoveries was the scanning tunneling microscope, and while it's mainly designed to measure the objects at nanoscale, it can also move tiny objects such as carbon nanotubes. The earliest example of this type of process, that is moving matter at the nanoscale, was accomplished by IBM, that is International Business Machines, on 11th of November 1989, and this was done by researchers called as Don Eigler and his colleagues, and they basically spelled out the company logo, that is IBM, in atoms. He and his team were able to literally move the 35 xenon atoms on the background of copper atoms to spell out IBM. As you can see in the image here, the background is the copper sheet or atoms, which is made up of copper atoms, and on top of that copper atoms, they have moved atoms, individual atoms, and spelled out I, B and M. So this is the very first application, or the process to show how we can manipulate matter at the nanoscale. And this was just a peek into the ability of nanotechnology. Commercial applications are majorly included in these verticals, which are, so the first vertical is we have the textiles, and we have biomedical field, healthcare, food and agriculture, industrial applications, electronics, environmental applications such as.
Just a quick info, guys. Intellipaat is providing hot training mentored by industry experts, the course link of which is given in the description below. Now, let's continue with the session.
Wastewater treatment, pollution monitoring sensors, etc. And we also have renewable energy, and I talked about textiles already. So we have these verticals, and inside these verticals we have sub applications within it, and using 2 or more verticals also we have applications. And now let us take a look at some of these applications in brief. Obviously, we can't talk about all of the applications. I'll be discussing some of the applications in brief. Nanotechnology has applications in the food industry, and nanoparticles like silver mixed with polymers are being used to enhance the quality of food packaging material, therefore increasing its shelf life, and it lasts longer and tastes better as well. And apart from that, we also have smart packaging, that is, a man is holding smart object in his hand, that is a sticker with silicon path ingrained in it, and it basically tells you how much it is. Furthermore, smart packaging through which biological changes occurring in the food are detected, and it is also one of the significant applications of nanotechnology. Next, we have electronic devices. With the advancement in technology, we have shifted from the bulky television sets and mobile phones to sleek TV sets and smartphones. Moreover, the use of nanomaterials like graphene, thin and lightweight, and better quality TV screens, which also consumes less power than the traditional TVs, have been invented using nanotechnology. And the next application is in the medical field. In this field, various treatments and medicines for chronic diseases like cancer and brain tumor are given out, and nanoparticles are being utilized wherein the drug will be targeted to the infected cells instead of the whole body. Apart from this, a wide range of nanomaterials is being used to enhance the efficiency of imaging devices. Medical applications of nanotechnology are not only restricted to the aforementioned areas, but they are also used in gene therapy, wound treatment, etc. Next, we have textiles and fabrics. To make a piece of cloth wearable, wrinkle and odor free across seasons, specialized fabric with nano-sized silver and titanium particles are being used. This has led to the production of lightweight, thin and breathable fabric. The other applications of nanotechnology in this industry include making fabric that is stain resistant and improved durability. Next, we have the application in the automobile industry. The automobile industry has seen a paradigm shift in the past decade. Every now and then, new four-wheeler or two-wheeler models with cutting-edge technology are released. And this is yet another industry where applications of nanotechnology are visible. Various polymer nanocomposites like natural rubber, organo clay have been used in tires to make them abrasion resistant. That is, they basically last longer than the rubber tires. Furthermore, adding nanoparticles like tungsten nanospheres to car fluids has enhanced their mechanical properties also. And the next application we have is in the sporting equipments. Many revolutionary changes are being made, especially in the tennis and golf sports, with the use of nanomaterials like silica nanoparticles, nanoclay fullerenes, etc. High-end rackets such as you can see in the picture on the left, and we also have tennis balls through which air releases at a slow pace. So it is used in tennis balls as well, and it is also used in lightweight hockey sticks and golf clubs, which improved durability and long-lasting features. Now we'll move on to the final topic of this video, that is the future of nanotechnology. So basically, according to the scientists and researchers, nanotechnology is predicted to have 4 distinct generations of advancement. We are currently experiencing the first or maybe the second, the start of second generation of nanomaterials. In the first generation is all about material science with enhancement of properties that are achieved by incorporating passive nanostructures. This can be in the form of coatings and the use of carbon nanotubes to strengthen plastics and other materials. The second generation makes use of active nanostructures, for example, by being bioactive to provide drug at specific target or a organ. This could be done by coating the nanoparticle with specific proteins. The complexity advances further in the third and fourth generations, starting with an advanced nanosystem, for example nanorobotics, and moving on to molecular nanosystem to control growth of artificial organs in the fourth generation of nanomaterials.
Just a quick info, guys. Intellipaat is providing hot training mentored by industry experts, the course link of which is given in the description below.